Hello, I'm Doug Eicher, and I'd like to introduce you to the Joist Wizard. This tool analyzes your joist geometry and loading requirements to help you determine the most cost-effective joist depth for your project. It also helps you to estimate various properties of the joist, including weight, moment of inertia, and maximum allowable duct sizes. Let's jump in. Okay, so to start off, we start with the tool on this home screen, and you'll notice here off to the right-hand side, we have our project info. So the first 4 fields of this are just header information about your project, and really they're just only used for the report that you can generate at the end. So they're optional inputs. If you want to put them in, you can, but they're not required for the tool. The next option is the design method, so you can choose either ASD or LRFD for your design. And next we have our load type. So this is for a pretty particular scenario where for say like your wind and seismic loads and also for your snow loads in ASC 722, if you want to give us the loads where you've already applied the factor of like 0.6 or 0.7 for seismic, you can do that and you can specify your load as service level. But by default, the tool is just gonna have this ultimate, which means that we're assuming all of your loads are given to us at code level or at 1.0. And most of the time, that's what you're gonna use for your project. It's just that you can select this if you want to give us the loads with those factors applied. And that only applies to ASD design. And then next we have our design code. And so here you can choose either 716 or 722. And that's really just going to be used to determine which load combinations you run for the analysis. And then down here is an option. If you want to save your work to come back later, you can click this Save Record button, and we'll go into a little bit more detail about how that works here in just a minute. Okay, so moving into the rest of the tool, you'll see here at the top, right now it's just blank, but as you start to put in inputs, you're going to see this screen populate with a parametric joist view. So it's going to show the length of the joist and the loads that are applied to it and just kind of give you a visual representation of your inputs. So starting down here in the specifications, this is going to be your basic information about the joist. You'll notice here we have this composite toggle. So this tool does support composite joists. And so if you click on that, that will give you some additional inputs, which we'll cover here in just a minute. Down here we have our span. That's going to be like our grid line to grid line dimension. You can apply depth limits. So if say you have like a headroom requirement for your joist, you can select yes, and then it'll give you an option to put in your min and max depth. We have our tributary width. So that's what's going to be used to calculate the unit loads that are applied to the joist from the area loads that you're entering here on the interface. And then we have our live load deflection limit. If you have a deflection limit you need to meet with the joist. So going down, we have our uniform load section, and you'll see here we have this toggle at the top for our advanced mode. So by default, the tool opens in kind of like this basic mode, which is really just meant for like a uniformly loaded joist situation. But if you have more advanced loads, maybe like distributed loads, like drift loads or concentrated loads or things of that nature, you can click on this toggle and it'll give you some more advanced loading inputs. And we'll go over those here in just a minute. But aside from just our basic uniform loads, we also have this add self-weight option. And what this will do is if you decide that you don't want to include the self-weight of the joist and bridging in your specified dead loads, you can select this. And then in the analysis, the tool will add the self-weight in and then also add a note on the report that just indicates that that self-weight needs to be added by Vulcraft when we design the product. So here at the bottom, we have our uplift input. By default, the tool is going to assume that you're giving gross uplift. So in the background, it's going to run that net uplift calculation based on what you gave it. But if you want to, you can also select net uplift, in which case it'll just take that value you gave it at face value and not run that calculation. Okay, so we talked about our advanced mode. Let's go ahead and take a look at that. If I come down here, I can either use this toggle or the one up here on the right-hand side. Either one will do the same thing. If I select that toggle, now you'll notice that we have a few more input options. So this looks pretty similar, but now you'll notice we have, like, for instance, this TCXL and TCXR. So those will be used if you want to have the top chord extend past the grid line dimension on either side of the joist. You can input those lengths here. We also have a slope input if you have a sloped joist. We also have a minimum I input, so if you're trying to meet a particular stiffness criteria, you can input your minimum moment of inertia value here. Under the uniform loads, you'll see that looks pretty similar. We just have a few more options now. one thing you'll notice here is we have dead and dead collateral loads. So those are essentially the same thing. The only real difference between them is that if you enter dead load, that will be subtracted in the net uplift calculation, whereas dead collateral won't be. So an example of this would be like the weight of your roof structure would be dead load, because that's going to be something that's permanent, that's going to be reliably there, whereas dead collateral might be akin to something like hanging light fixtures from the bottom of your joist cord that might be subject to change or might be removed. And then we also have a rain load input. Now keep in mind, this tool does not do a ponding analysis, so this rain load will just be applied like a regular uniform load. And then we also have a downward wind value. Again, you'll notice the load label here, 1.0W. That's because we have the ultimate load type selected. If you were to select service level, you'll see that the label changes to that 0.6W. And then for the uplift, it's pretty similar. The only real difference is now you have the option to do zonal uplift. So if, say, your joist is right at the edge of a transition between two zones, you can select zonal uplift, and then that gives you the ability to input zones with different magnitudes and different start locations and lengths. Okay, and so now we get into kind of the biggest parts of this advanced mode. Here we have distributed loads. So let's say that you have like a drift load in your design. This gives you the option to input a load that either has a different start and ending magnitude, or maybe it doesn't span the whole length of the joist. So here you can put in those start and end magnitudes, and then also your start locations and lengths. We have concentrated loads as well. Again, those are pretty similar. You'll notice this add load option over here. So what this would be used for is, let's say you have like a rooftop unit on your joist, and you know that you're gonna have 2-point loads applied to the joist, but you don't know exactly where they're going to be. In that case, what you could do is you could take those two concentrated loads, sum them together, and then take that value and apply it as an add load to the joist. And what'll happen is, in the background, when the joist gets designed, it'll be checked for that load at every panel point across the span. So that way, that joist is gonna be good no matter where you put those concentrated loads. So that's an option you can apply in this tool as well. And then we have axial loads. If your joist is part of the lateral system, you can input those here. Notice you can select if it's top or bottom chord. You can also select a transfer method. So you can choose to put it through the joist seat or through some alternative means. Just keep in mind that if you select the joist seat, there are some additional restrictions as to the capacity, as to how much load can go through there. And then we also can choose if we want it to be wind or seismic for the axial load. And then we have our magnitude over here. We also have end moment input. So if your joist has fixed ends, maybe you're part of a moment frame, you can input those here as well. So you can select if it's a gravity or lateral moment. And so basically that's just indicating whether the moment is being applied by the gravity loads or as part of the lateral force. And then you can select which end you want to apply the moment to. Again, the transfer method you want, and then the load type. And just keep in mind that based on what you put over here for the moment type, it's going to give you some different options for your load types. And then you have your magnitude here. Okay, so now that we've covered the advanced mode, let's go ahead and go back to our basic mode. And you'll see here, I get a pop-up that just says, hey, just to make sure any of your advanced inputs are going to be cleared if you do this, do you want to do that? So I'll click yes. And so now we go back to our basic mode. Now let's scroll back up to the top and let's look at our composite design. So if I click this toggle, first of all, you'll notice this little pop-up that comes up. This is just letting me know that since I am doing a composite design, which incorporates concrete, that it has to switch the design type to LRFD in this case. And so it's just giving me a heads up that that's done. Okay, and then right here at the top, you'll see this header that comes up. This is just letting you know if you're designing a floor and vibration is a concern for you, that we have some resources available where you can take a look at our flush frame connections that perform really well in vibration. So there's some links to resources here where you can get more information about that. And then down here below the diagram, you'll see this note. This is just letting you know that here on the front end, while you're inputting information, the non-composite dead load is not going to be displayed on the diagram because we just don't know what it is yet. We will determine that once we've determined the joist self-weight. And so this is just giving you a heads up that that will be shown on the report at the end, but it won't be shown right now on the diagram. And so down here, we have this additional input for the slab. So here we can input our deck profile, and note that there are both Vulcraft and Verco profiles in here. We have our topping thickness, which is going to be the thickness of the concrete above the flute of the deck. We have our concrete unit weight. We have our concrete compressive strength, and then we have a stud cost. And so this will be used when the tool runs a comparative analysis of different joist depths. So we have a default value in here, but if you want to change it for your market, you can do that. So here we have our uniform loads, and again, we have our advanced mode toggle here if you want to input some more advanced loading, but by default, we just have our basic uniform loads. Here we have our superimposed dead load. So that's going to be the dead load that's applied above and beyond the self-weight of the deck, joist, and slab. So those will be calculated during the analysis, so all you have to do is input the load above and beyond that. We have our live load, and then also our construction live loading as well. All right, so now that we've looked through all the inputs, let's go ahead, let's refresh the tool. So we're starting from scratch, and let's go ahead and run some examples. So we'll start off with just kind of a basic example. We'll go ahead and input a joist span. And you'll see now as I'm starting to input information, this diagram is starting to populate. We'll input a depth limit. So by default, you'll see some values come in here based on allowable span to depth ratios per SJI. So we'll go ahead and limit this to 30 inches for our depth. We'll set our tributary width to 6 feet, and we'll leave the live load deflection limit where it's at. Next, we'll come down here into our uniform loads and we'll apply some loading here. We'll go 10 PSF for the dead load, 20 PSF for the live roof, and 25 PSF for the snow. And then let's go ahead and apply an uplift value of 16 PSF, and again, that's going to be gross uplift. And then let's go ahead and run the analysis. All right, so now we get to the analysis page. And first off, you'll notice that we have one of these highlighted in green. And the reason for that is that's indicating that this is the most cost-effective depth option. And so you'll see it's run a few different depth options here, and it's just highlighting the one that's most cost-effective. Right here on the left side, you'll see the designation. And you'll note that this is not a standard SJI designation, but instead this is a total over live designation. And the advantage with this is, with a standard SJI designation, you have to figure out all of your loading. You have to then go to the tables and try to find your nearest SJI designation. But with a total over live designation, really all you have to do is just give us the exact loads that you have. And so it's a more efficient way of communicating loading, and it's going to get you a more cost-effective product. So here you'll see these loads are unfactored, first of all. And you'll notice that here we have our joist depth, we have the series, and then we have the total load. So that's going to be your dead plus live load, and then your live load indicated here. And then next we have our cost ratio. So again, it just shows the comparative cost calculation between different depth options. We have our self weight. So keep in mind that's going to be the weight of the joist plus the bridging. And you'll notice there's a little note here just indicating, hey, make sure that you've included the joist self weight in your specified dead load. We have our moment of inertia. And again, there's a note here just indicating if you have a certain stiffness requirement that you need, make sure that you provide that to Vulcraft, because these moments of inertia are estimates. They're not necessarily exact values and could change on final design. But if you have a requirement, just provide that to us and we can make sure to design the joist accordingly. Next, we have our live load deflection ratio. Again, another note here just indicating that these calculated deflections have been increased by 15% to account for shear deformation per SJI. We have the top chord width. So this is going to be the total top chord width. So the width of both chord angles plus the chord gap between them. We have our bridging requirements. So in this case, it looks like we have 2 top chord rows required and then 3 bottom chord rows. We have our minimum seat depth. And then here we have our max duct sizes. So these are estimates of the maximum size ductwork that can fit through the plane of the joist. There's a note here, so if you have ductwork that you need to fit through the plane of the joist, it would be good to go ahead and provide those sizes and locations to Vulcraft. That way we can make sure we can design around them, because these are just estimates at the end of the day. All right, and we'll talk about the report in just a second. So let's go ahead and go back to the inputs. And let's take a look at, say we have a case where we have slightly more advanced loading than what we had here. So in that case, we would click this advanced mode, and now we have some different options for our inputs. So in this case, we're going to change a couple things. We're going to change the depth limits to no. So we're going to leave it run wide open. We're going to go ahead and add a top chord extension on the left end. So we'll add it here at 1.5 feet. And you'll see this 1'6" come in here on the left end side as the diagram updates to give that information. We're going to come and add in a slope. So we'll say 1/4 on 12. And now you can see the diagram is updating to show that slope. And you'll also notice how it separates the loads applied by the environment versus the dead load in relation to how they're applied to the slope. For uniform loads, we're going to keep things pretty similar, but we're going to go ahead and add a downward wind load of 16 PSF, and we're going to check this add self-weight option. And then down here under our distributed loads, we're going to add in a drift load. So we'll select our snow. We'll say our start magnitude is 38 PSF. And now, one note about the start location. So if we were to say leave this at 0 and put in our length, you'll notice if we come up here to the diagram, our drift load is actually starting at the end of the TCX, not quite where we want. So the way that this tool works is if you have a top chord extension on the left end, everything to the right of that grid line dimension is a positive dimension. Everything to the left is a negative dimension. So in my case, if I want my drift load to actually start right here at the very end of the joist, what I would do is I would come down here and instead of 0, I would set my start location to -1.5 since we have that top chord extension. And so now you see that load is moved to start right here at the very end of the joist. For our concentrated loads, we'll go ahead and add one in. We'll leave it as a dead load. We'll give it a magnitude of 1.8 kips and we'll say it's located at 32 feet. For our axial loads, we'll leave all of these inputs at the default, and then we'll just put in a magnitude. We'll say 12.5 kips. And you'll notice then if we come up here, you'll see how the diagram's updated and is now showing that concentrated load over here, along with that axial load on the joist top chord. And we're not going to worry about end moments for this example, but if you wanted to, you could apply an end moment, and we'll just show you what that would look like on the diagram. If I enter a value, and then I come up here, you'll see on the diagram it's updated to show that moment at the correct location, and it shows the magnitude and the load type. But for this scenario, we're not going to have a moment, so let's just zero that back out. Okay, and then just so you can kind of see what that looks like on the report, let's go ahead and put in some project information. That way we can go ahead and see what that's going to look like on our report. So we'll just put in a project number. Okay, we'll put in a project name. We'll put in a design mark, and then we'll put in an engineer. And then let's go ahead and leave this as ASD, but let's switch the design code to ASC 722. All right, let's analyze. Okay, so now we've gotten our results, and you'll notice right away we're getting a little pop-up here that's just letting us know we're getting an SP designation. So what does that mean? Well, that really just means that in this case, the loading that we have is a little too complex to be specified just through a designation alone. And so in this case, it's telling us that we need a load diagram or a schedule, which we can do with our report that we'll talk about in a minute. Just notice here before we go to the report, we do have this header that's just letting us know that the joist self-weight has not been included in the designation loading, and so you need to make sure to notify Vulcraft that they have to apply that over and above the specified loads. And then one other thing down here, we have this equivalent uniform load section. So we actually don't recommend using equivalent uniform loads to specify a joist, as you could have cases of stress reversal in the webs in the center, and so you might have your joist webs be under-designed. But this is just given here to kind of give you a window into how the tool is estimating joist properties. So if you select a load combination here, you can see all the different ones that the tool ran. If you select a load combination, now you'll see the moment and shear envelopes for each load combination, and you'll see this differentiation here between the equivalent shear, which is marked out in kind of this blue color, and then the actual shear, which is noted here in more of this purple color. And you'll see how that's being done as it calculates those moment and shear envelopes. And you can see the same thing down here. And for each one of these, if you hover over it, you'll see a little pop-up that'll give you the values at that location. Okay, let's go ahead and generate a report. If I click on this, now I have the option to select which depth I want. Let's hit generate, and then you'll see it spin for a second. And now, if we open this, now you can see this report that's opened. We have a nice load diagram here at the top, so it shows all the loading inputs that we had. And then here you'll see we have that identifying project info. And then we have some basic information about the tributary width and the deflection limit. And then down here, we have the results that we got from the tool. So you can print this out and you can put this right in your calc file if you want to. Okay, and then let's go back to the inputs and let's take a look at one composite example. So we're gonna refresh the tool one more time, so we're starting from scratch. Let's go ahead and select this composite toggle. And now let's input some basic information. So we'll put in our span. We're gonna go ahead and leave the depth limits to run wide open. We'll put in a tributary width. And you'll notice now that deflection limit has defaulted to L/360 because it assumes it's a floor. You can change that if you want, but that's what the default comes into. We're gonna select our 3.5-inch dovetail, and then we'll put in a topping thickness. Now keep in mind, again, this is the thickness of the concrete above the flue to the deck. So in this case, we're gonna have a total slab thickness of 6.5 inches. We'll put in our concrete unit weight. Let's put in our concrete compressive strength. We'll leave our stud cost at the default. Let's input our superimposed load, our live load, and our construction live load. And then let's go ahead and run the analysis. Okay, so this looks pretty similar. The main difference you'll notice is the designations look a little different. So for composite joists, the designation has 3 parts. So the first part is going to be the total load. So it's going to be the non-composite dead load, the superimposed dead load, and then the live load. And then the second part is going to be the live load, and then the third part is going to be the superimposed dead load. And again, these designation loads are unfactored. And then the only other additional field is going to be the shear studs field. So this is giving you an estimate of the shear stud requirements for this particular joist depth. In this case, it looks like we would need 22 shear studs, and those would be a 1/2 inch diameter. But everything else looks pretty similar. And again, you can generate a report for this if you'd like to. So if I click Generate Report, and then I select the joist depth that I want and hit Generate, it will generate a new report for me. And then here you'll see now we have this additional non-composite dead load that is calculated based on that joist depth. But everything else looks pretty similar to the other report. Okay, and if, say, you want to save your work and come back later, or maybe you want a colleague to take a look at your work, you can click this Save Record button. It'll generate a record key for you, which you can then copy to the clipboard. And so if, say, you wanted to come back later, like let's go back to the inputs, let's clear the tool so we're starting from scratch. If I click Load Project, I then drop that record key into there, I hit Get Record, and now you'll see that all of those inputs have loaded back in, so that way I can come back to it later. And then lastly, we have a couple additional pages. So if you click on this drop-down menu here, we have a frequently asked questions page. So if maybe there's a particular question you have, you can come in here, you can select that question, and it'll give you the answer here. We also have a technical revisions page. So if you're interested in seeing what's changed between the last version, you can come down here and see those changes listed. And then we also have an additional licensing page, which is just here for legal reasons, that lists the different licenses for the components that we've used in the making of this tool. And that's the Joist Wizard, your go-to resource for determining the best joist option for your design. And with that, happy specifying.